Good morning, good afternoon, and good evening. I'd like to welcome you to our third webinar in the last 3 weeks. Today's webinar is about archiving best practices, what we like to call 3-2-1. Before I get started, just a quick little review. Our first webinar was defining data storage, where we talked about a number of different types of storage products that you have to choose from when building out a workflow. Then last week, we spent time talking about the collaborative tools that we would use and how we can build out those workflows. Each of those have been recorded. Each of those can be found on our website. If you can't find them, please ask your channel partner to direct you to it. Today, we're going to talk about the archiving best practices, and then next week, we're actually going to spend the entire hour, and actually might extend this out to about an hour and a half, of going through all of the individual workflow tools, HyperFS and Strawberry, the UIs for Genesis, RX, and DX, and actually do the demonstrations for you to show you the unique attributes of these products. Again, going back into last week, talking about the different product lines, the NAS, the scale-out NAS, the block level volume versus file level, and the block level and scale-out. Those will really be shown off in a much bigger way next week. But this week, we're going to talk about archive. And I put up here archive and backup. I put that up for a reason because a lot of people get that confused, and I don't want you to confuse that at all. Backup is what we consider recovery. It's a day-to-day thing that's going on, if not an hour-by-hour thing that's going on with your primary data. So if you do have any issues within your facility and you need to go back in time, you can recover that information, that primary data, and be up and running with very little loss of data, if any. Where archiving is more of a discovery. It's where you're taking finished projects, more stale data, and you're moving that into a long-term archive for preservation that you can access at a later date if needed. Backup and archiving work side by side and are complementary to each other. We're going to talk about 3-2-1, archive best practices. It's 3 copies of your data on 2 types of media and at least 1 copy that's kept off-site for disaster recovery. First, I want to look at archive, fiber channel versus NAS, disk, and tape, and using these technologies for your advantage. So when you're building out your archive, the first thing that's extremely important, specifically to media and entertainment and creative, is it needs to be easy to use. We need to be able to go in and set up the archive so that there's processes in place that drive automation, where the users, the editors, and the content distribution guys, they don't have to spend a lot of time trying to figure out how and if their media is being preserved and archived. We do that, and we'll go through that in a great amount of detail, where I might get very redundant in this particular webinar. I think that's all part of that 3-2-1 concept. I've got to show redundancy, multiple copies. So you're going to see me talk about things over and over so that archiving becomes a very easy, understandable way of protecting your data. Low cost and reliability is also, when we're archiving, we're taking months and months and years of data, we're putting it back on some type of storage, and so low cost becomes a very important part of the puzzle, as well as making sure it's reliable, so when I do need that product back, when I do need that media back, it's there. Tape is still the lowest cost storage. Depending on how it's being used, you can argue that disk can be lower cost, but for most practices today, tape is still the lowest cost and lowest cost on the environmental usage as well. However, we talked about in prior discussions about object storage, and when you get into that multi-petabyte or petabyte and above, there is a case where object storage can be less expensive overall than doing tape and more reliable. So there's ways of measuring that, and it'll depend on each customer's requirements. Fiber channel or NAS, we definitely see improvements in archive. And you can archive straight to tape, either through tape drives or into libraries. But there's a huge advantage by putting a cache disk in the middle of that. And there's a lot of things you can do with that cache disk to keep second tier disk retention up front for 3 months, 6 months, 9 months, and then move it to tape. Or you can just use cache simply to align up your archive and stream it down to the archive device more efficiently. So there's quite a few reasons that we'll go into that would allow you to determine what size cache that you'd want to put in the middle between your primary storage and your archive. The products we're going to talk about today are going to be layers of software that will go on to the Genesis IAP server. We've got the Archive Manager. The Archive Manager is basically the storage virtualization. It creates that active archive. And with Archive Manager, you can build out multiple archives within one Genesis IAP server. So you can have an archive for graphics. You can have an archive for post. You can have an archive for visual effects. You can have an archive for whoever. You can have multiple archives set up off of that one server. We also have an optional piece in there that is Archive Replicator that allows you to do replication for disaster recovery. We have the ability to, within Archive Manager, to do both HSM format, which is the proprietary format of the archiver, or you can go to standard LTFS and UDF. And I will talk more about the LTFS because this is a buzzword within our market industry and definitely being used across all of your customers. Storage management software also includes the Genesis Network Migrator. And the Migrator is what allows us to set up the policies and the tiered storage for better lifecycle management. Being able to manage multiple pieces of storage and being able to automate the process of moving from primary to secondary out to a tape device, and then out to disaster recovery or out to the cloud. So talking about the network migrator, again, policy-based for tiered storage, we automatically migrate, move, or copy static and or unstructured data from primary storage. I'll show a screen here in a little bit that shows how that works, but you set the policies, or we give you best practices to set those policies for the customer so that so it becomes an automated piece of their workflow and they're not worried about backup. It's really important for our customers to start doing archives, start having this as a best practice within their own continuity for their business. We've all been there. We've all sat there with individual customers who have given us their backup or archive nightmare or their lack of, where they're saving all of their work on hard disk or USB drives, and they're putting them up on shelves, and 2 years go by, a year goes by, they need a particular asset, they go to get it, and that drive will not spin up, or it was dropped, or whatever the reason, the data is corrupt. Putting an archive policy in place for our clients is our responsibility so that they don't have those issues in the future. That is their intellectual property. We need to show them how to save that data correctly. By having automated processes, you're going to reduce the amount of backup, you're going to reduce the recovery or you're going to increase the speed for recovering that data, and you're going to be optimizing your storage and how you're using various different pieces of media by not allowing it to take up long-term space on primary storage. A lot of features built into the migrator. We support a number of different operating systems, but really in the M&E space, we focus primarily on the Windows. We found that to be the best operating system for the archive, for everything that we need to do within the appliance. Linux, Unix, Mac, we've used that. And this again is at the this is the agent level. We'll support all the different agents, but at the server level, I guess is what I was talking about. That's a Windows-based server. But on the agents, Linux, Mac, Unix, your clients, you can have all that coming in, along with some enterprise clients as well, like NetApp and HNAS from Hitachi Data Systems. Operating system stubs. This is extremely important, especially when we're hooking things up into a high-performance archiving network with HyperFS. These stubs allow the information to stay online for the client. So the data all looks like it's there, and they just have to basically pick that data. They don't need to know where it is within the multi-tiered storage. They can just pick that information, that file, and it'll go retrieve it and bring it back in. Very scalable, up to billions of files, and we'll go through more of that. Priced solely on the capacity being migrated. A lot of enterprise level archive solutions out there, they will quote you pricing on the cache disk, on what they're managing, the capacity of the library, quantity of drives, and off the shelf when you're moving it from the library out to a disaster recovery area or Iron Mountain. They'll charge you for all of that data that they're managing. And what we've built in this archive solution is a single pricing model that is just about the media that's being migrated off of primary storage and the amount of drives that we're managing. Those are the criteria. So it's really the tape library that we're working with is how the modules are going to be priced. So now we'll start to build this out for you. I wanted to give you a lot of background of the different things that it's capable of. But now we'll start to build it out so you can visually see what we've got and then how it all works together. And this is that redundancy part I was talking about. So we support lots of different operating systems around the around Windows, Linux. There you go. Windows or Linux. I wonder if I could create a new operating system, Linux. I think I may do that. Windows or Linux, and we again focus on the Genesis IAP. It's a Windows server. Within the IAP, you can have fiber channel, SAS, or SATA. We focus on fiber channel and SAS in our configurations. Ethernet, 1 gigabit, and you can have multiple 1 gigs and bond those together. But your sales team, your partners out there, they're going to focus in on 10 gig. It's a better experience overall with archive, especially in this market. So we're going to focus on getting your customers to add a little extra dollars in their budget. Make sure the IAP server is either 10 gig or fiber channel. And then open one or many fiber channel or SAS connections onto the library. Again, that depends on the size of the libraries. LTO, LTFS, right now LTO5 or LTO6, primarily onto the LTO6 side of things. So we take that Genesis IAP and we take the library, we put that together, we build up our policies, and that's as easy as it looks. It's a lot more complicated than that. There's other decisions that we have to make as well. I talked about the proprietary, or what we call the TDO, tape disk object file system. This is part of the HSM, the hierarchical storage management. It's a proprietary format that allows higher performance and more feature-rich archive capability than what LTFS does. And the real restriction there is that when you're writing in the TDO, it also will have it tarred up for you, but if you're writing in TDO and you want to go to another facility, it also has to be based around the Genesis archive for it to read it in that other facility. So it is proprietary in nature, but designed for libraries, automatic media spanning, so you can just continue to archive the tapes and it's going to span across multiple tapes. Metadata for the total archive and much faster for doing that streaming performance. Now you move to the other side of this chart and we talk about LTFS, linear tape file system. It's taken on in our market quite a bit over the last couple of years, and it's come a long ways. It was designed primarily as taking an LTO5 or LTO6 drive and turning it into almost like a USB, where it had a file structure and it looked like a disk drive for you versus traditional tape. That was the whole goal behind it. It wasn't designed to be put into libraries or managed through any of the hierarchical storage management middlewares. So it was designed just as a standalone drive device. Didn't have the capability of doing spanning, where if you were writing more than the size of that tape, you could automatically move it over and put the rest of the content on another tape and keep track of that. So it didn't have that as well. It wasn't as high as performing, so you had streaming issues and slower performance in getting the information down there. And there was a number of characters, or is a number of characters that are not supported, which can cause some havoc as well. So there's some caveats still with LTFS. Um, to give you a visual to explain that a little bit more, up on the top here, we have a standard LTFS library approach. And what that does is it turns every one of the drives into, depending on what tape we've got in there, in this case, a 1.5 terabyte tape. I've got 4 tapes in there. I've got 4 individual drives that are 1.5 terabytes. That's how it visually looks to my customer. Again, remember, no spanning. So if I reach the end of that 1.5, I'm going to start up another tape, and I'm not going to know that those two are connected. You throw the Genesis IAP in there, and we then have LTFS spanning as an option with the archive manager. Now you've taken tape 1, 2, 3, and 4, and they become a 6 terabyte volume that allows you to span across multiple tapes. We're gonna cover that again and again. Here's what a basic um, archive would look like. So we would use that Windows server. We would decide if it's going to be fiber channel or SAS or iSCSI connected up into a device. That device could be a tape library, an optical library. It could be object storage. It could be the RDX technology. We don't really have limitations on what's supported on the back end. We support so many different types of devices. We put that cache in the middle. You've got an archive manager that's your primary, and you can build in a secondary as well for failover. Take that a little bit further here. We've created an active archive with that Genesis IAP in the middle and the archive manager on there. And now we've got, up on the top left here, we've got a bunch of clients running off of primary storage. And here we just got a manual archive. So what they can do is they can, via CIFS or NFS, they can just push their media over to the IAP server uh, manually as they see fit. The IAP server then is going to take it and through its policies determine if they leave it on the IAP storage and the cache behind it, or if they're going to move it to some other second or third tier storage. Or in the case down here below, we're using automatic rules that says when we're ingesting into primary storage, we automatically want to move the data over to the IAP, which is then going to take it and move it. So there's 2 ways of doing that. There's multiple ways of doing it, but here's 2 options of either having a manual archive set off or an automated archive set off. Here's a much bigger picture. So what I've taken here is put it all together with multiple operating systems, multiple clients on the left-hand side. You see Windows, you see Linux. We've got Oracle, NetApp, Hitachi, everything. Those are our clients. Those are our agents. We've set up multiple archives there. Up in the top middle, we've got our network migrator. And this is our database. This is the Genesis server. And that's where we're going to set our policies up. That's where the stubbed information is going to rely on. And if you remember when I talked about the stub, it basically makes the file look like it's still there, even if it is off on the archive. This is where we're going to set policies of migrating, copying, moving, deleting off of the cache disk. It's also where we've got all our reporting and monitoring. From a user experience standpoint, we've now automated the data movement and we've made it very transparent within their workflow. We've given the user access that is unaffected now with the stubs, like I said, because it looks like the data is there and they don't need to know where to go look for that data. We've also set up in this situation that we've got a second tier of storage. So we're going down here below into the second tier of storage, low-cost SATA disk. And the key to that is once you get to understand your customer's requirements a little bit more, the data is moving from the agents over to the cache. The cache is there primarily to just streamline the archive process. You put the second tier storage as a spinning disk where you might want 50 terabytes or 100 terabytes worth of cheap, inexpensive spinning disk because this is your work in process. This is your WIP. This is where you're going to have finished media. You're going to push it off of your primary storage, put it onto that spinning disk, and you're going to wait a month or 3 months or 6 months while you're waiting for client reviews or you know he's going to come back and do something else with it. So you want that data accessible and you want to be able to move it from that second tier archive back to your primary storage very, very quickly. A lot of our customers are doing that. They're putting in that disk layer now that's giving them a good 6 months to a year of spinning disk storage. At the same time, our network migrator is polling that storage based on the policies we've set up. And a policy can simply be that if that data has not been touched in 1 month or 3 months or 6 months, or if it's a particular type of file, it wants to migrate that and move that on to some less expensive. That's where we're moving to the tape, the optical, the RDX, or out to the cloud. Or it's looking for a disaster recovery plan and it wants to do that, move it out. This is all built in and automated for that customer so they don't have to worry about it. The network migrator, just wanted to give you a screenshot so you could take a look. We're going to demonstrate this next week in more detail, but it's the policy builder. So this is where you're taking your information based on your workflow and your file structures, and you're setting policies across the files, across the groups, and it's got the ability to dive really, really deep into it, or it can also be extremely simple. We focus on the simplicity of it with our clients mostly, but if they need to go deep into the policies, we certainly have the ability to do that and consult them on that as well. Those are all the basics that are tied around the archive manager. And so this simulation here gives you an idea of how we build it. We're going to choose our storage, so our integral volume. We're going to choose what kind of medium we want our archive to be on. We're going to put a cache in place. We talked about all the benefits of why cache is important for streamlining the archive. So we're going to have a cache there. Then we're going to put in our archive manager and start to write our policies on how we want data to move. Our cache is going to look to our client stations as the F drive or the archive drive or whatever it is. And we're then going to start to move data. Now that's a manual move of data, goes into the cache puts to archive, boom, we're done. The next movement is going to be more of an automated. As they're writing data, it's looking at the policies and then it's moving it into the cache. The cache is going to fill up at a certain point. And when it fills up, it needs to do something with that data. You don't want to keep writing to a full cache, obviously. So based on the policies, based on the migration path that we put in play, the cache is going to then start to write and streamline the archive process. So that may be one of the goals is you've got a 20 terabyte cache sitting there and you're going to move 20 terabytes of files off and it's going to go to the cache, fill up the cache, and then it's going to stream it to the archive. And one of the advantages of that, especially in utilizing tape, is it takes away what we call the shoe shine effect with tape, where it's constantly moving the heads back and forth, writing data back and forth on the tape, and it wears out your tapes quicker, it wears out your tape drives faster. So by being able to cache it and stream it into that archive, you lengthen the life cycle of your tapes and your library. Once that's done, you want to move a copy off the library and out for disaster recovery. So you've got that copy feature. Volume library is all part of the Genesis Archive Manager. It's going to keep all that information that allows you to keep the file online for the clients, so that stubbing file. As I mentioned, you can also have multiple archives, so you would set up separate caches for those multiple archives, break them up in volumes. So your graphics department has its cache it's going to, and your VFX has its cache it's going to. What happens next? Now we've got the two different archives in place, and it's out there writing data simultaneously into the two caches and going into the preferred archive device. So that there was a completely automated process for building out an archive for media and entertainment that attaches into the rest of our workflow. I want to talk a little bit more as well about the LTFS, and so you understand that and where it's being used. LTFS standard or volume spanning, as we put it into the Genesis library. LTFS supports Windows and Linux right now. LTO5, LTO6 based libraries, also Oracle and IBM. LTFS has primarily been used in media and entertainment, and in library usage, it's been used as just individual tapes, and you would write your project, write your file onto one tape, and it would keep track of 1 to 60 tapes in this library. It does work in cooperation with MAMs or DAMs to manage the media, but no spanning. Remember, in a typical library, there's no spanning. Where an LTFS volume under the Genesis archive, you are going to put the spanning feature in place. You're going to take that same quantity of drives and you're going to build those out and grow them as you build the network out. And it's just going to look like one big volume if that's the way that you want to do it. Wanted to make a point on HyperFS as well. So the Genesis works across multiple different applications. And it can be used without HyperFS. It can be used just on a gigabit network. It could be put in some other network topology. It's an appliance. It's an archive appliance that doesn't really care what the I/O is. So you don't have to worry about that. If you're just looking for an archive to an existing configuration, we can lay the Genesis Network Migrator right on top of that and do all the things that we said we were going to do. But over the years, we put a lot of effort into integrating this into the HyperFS file system as well to give you a more complete overall solution and allow you to take the IAP server and connect it via fiber. And what this does is it allows you much better performance to your archive and really when you're retrieving your archive back. You can retrieve your archive right back into that fiber channel SAN and put it, give access to those clients very, very quickly. As far as the diagram is concerned, it's what we've covered already. Multiple different client operating systems, Mac, Windows, Linux, giving high-speed access into the SAN and also into the IAP server for managing the SAN and moving that out into the archive. Talk a little bit about its scalability. As Scale Logic, we like the word scale, and that's how we design our product lines. So capacity, we support billions of files. Disk cache requires such a little amount of information to keep that stubbing in place, so 1 KB per file. RAM requirements, we can grow 16 to 64 gigs depending on the size of archives and multiple archives that we're doing. Larger libraries or offline media for scaling out the size or going to object storage. We've got that built in as well. Single LTO6 drive can write 4.7 petabytes in 1 year, 24/7 operation. I did not know that until I started putting this together for all you guys. But one drive can write up to 4.7 petabytes. So that's capacity. How about performance? Performance, we've got LTO6 drives right at 160 megabytes a second. You can have multiple LTO6 in your library, and very important to doing all of this and sizing it. This is where our team comes in to help you, to consult with you and the customer to size your archive correctly, put the right amount of drives in there for the amount of archiving that you're doing, and then make sure that the disk is, in comparison, is matching so that you get the optimum performance. So those two lines are key. How many drives are we going to put in to drive the amount of archive data we're coming off of primary storage, and how much cache needs to be put in the middle to optimize the drive writing performance. So that's a huge thing I wanted to make sure everybody understood. Higher performance means more pipes, more connectivity, more complexity. So again, this is where you and I come in with the end customer to help support driving that. We also want to look at the read performance requirements as well. That allows us to position when you go into bigger archives, it allows us to position drives that are write drives versus drives that are read drives. Um, this is important to understand so that you can optimize the configuration within the library for the workflow. All this can be modified at times as well, but the more information we have up front, the better off we can in sizing the correct archive for you. Here's a chart that kind of gives you an idea of that sizing capability. Obviously, there's other things that are involved to drive the sizing, but as simple as it is, number of slots, 24, 48, 100. You look at the capacity that you're doing, and then you pick out best practices, how many drives I'm going to have in the system for writing, how many drives I'm going to have in the system for reading, come up with a total drive. That gives us our base unit for doing the archive. It also gives us the ability then to size out the cache that we're going to put in the middle and the type of pipes we're going to use to drive the overall archiving workflow. So all the things that I've covered in this webinar comes down to specific benefits for our clients. So we create an active archive and use a tiered structure for using their off-the-shelf CIFS or NFS and/or fiber channel. All archive data is accessible by the user or the applications. That's a key point. They don't want to go look through Excel spreadsheets or files to try to find their data or go look up on shelves to find the drive that's not going to spin up for them. We want to make sure that all of this data is right there at their fingertips. They push a button, tell it to restore, and they don't have to worry about it. The only time they have to worry about it at that point is if it was taken off the shelf and put on the shelf, or if it was taken and put at a DR site. It may tell them that the tape is not accessible, and they need to go get that tape and put that in a slot, and then it'll start to rebuild the data for them. Reduce backup in the enterprise. Reduces backup in the enterprise. Copy replication options for having those multiple copies. Remember the 3-2-1. We want 3 copies on 2 technologies and 1 off-site. Optimize primary storage and reduce storage costs. Major point there. These facilities, again, a lot of them are still the creative guys that are driving the creative piece and not the IT. And so they're not looking at the ways that they can optimize that storage. Now, there's a double-edged sword here. They could fill up their 100 terabytes of primary storage and have to buy another 100 terabytes of primary storage, except for the fact that in that 100 terabytes that they filled up, they may only be using 70% of it or 80% of it. So based on policies, they can move that data from primary to secondary and so on and so on. Managing that storage, putting the automation in that so that they can focus on the creative. We do have customers, not as much in the M&E space, but in the healthcare space, digital security, that look for worm technology so that they can't rewrite over the tapes or the media. And also key is, it's a very open software, open application, so it integrates into the chosen operating systems and security models that their clients have, so we can adapt to their environment. And that is mostly what I wanted to cover today. Going through the benefits of partnering with ScaleLogic. We've covered them in each and every one, but depending on the technology, there's some differences. So our experience in archiving isn't as long as it has been in the SAN or the storage, the RAID systems, but it's pretty close. We've got 15 years of building out archives as a team here. Multiple storage options, so we've got a broad product line of tape, disk, and cloud providers. multiple management options. We focused in on primarily one today. It's the primary one that we look at that solves the most problems, but there are other types of archive options that we have as well uh, that will meet other requirements for clients. So that's part of the consultative piece. We need to continually be looking at different options for customers. Not every software hardware solution fits a particular person's budget or workflow. Um, Modular product design, converged solutions. So much of what we talk about is already tested. It's tested in our interop lab. It's tested with our vendors, partners. It's tested with our ISVs under the applications. So we are not testing at our customers' facilities. And much of what we talked about today can go on the legacy equipment that's out there. So SANs that we've put out there from Rourke, or SANs that have been put out there from Apple or Active Storage or Quantum, we can go in with an appliance-based solution to solving their archive issues. Enterprise support as well. This particular package that we talked about today is supported on the complete HDS line, Hitachi Data Systems line, and on Hewlett Packard, among others. But those two are ones that we've worked with already and certified everything completely. You've got the professional services, and you've got the ability to do this globally. I'm going to go to some questions here in a moment. But I do want you to stay tuned for session 4 next Wednesday. That'll be the last of a 4-part series. Um, I won't be doing this one, but Daryl Hines will be doing it. We'll be taking 15-minute time slots to walk you through the actual UI of the product line. No more PowerPoint. It's going to be a live demo. We're going to talk about the Genesis RX and the user interface, show you how that works in immediate entertainment, some of the key unique features about it. We're going to work with you on the metadata controller and the HyperFS UI and how easy it is for a HyperFS SAN to be set up and managed versus a Quantum StorNext. Then we're going to go into what we'll consider a much more attractive demo, which is the Strawberry 4.0. We'll show you all the changes that have happened in Strawberry 4.0. We'll spend a little bit more time on that one. Definitely a must-see. And then what we talked about today, we'll just walk through very quickly that Archive Migrator, show you the features, the screens, and how you would set up an archive. So absolutely make it one more week with me and Daryl to see the live demos. That'll finish up your preparations going into NAB and really give you a good feel of the value that ScaleLogic is bringing with these products and driving them into a converged solution. So I'm going to take a moment here and see if we've got any questions, and hopefully I'll be able to answer them. Last week we had a ton of questions. This week I must have done an even better job because there's not a question out there. If you have questions, please just send your questions over to your director of sales, and we will get these answered and out to you. This session has been recorded as well. We now have all 3 sessions are recorded for your review. Take those links when I send them out to you. Send them out within your company. Feel free to send them anywhere within the company for other salespeople or technical people that would like to get a little bit more information on ScaleLogic, the product lines that we have. Encourage them to spend some time, if you liked what you heard, to get to know the product line a little bit better. And we will see you guys next week and do the live demos. Thank you very much. Appreciate your time and hope you enjoyed.